Welcome to today's video. Today we'll be working on question number 20 from LeetCode. And this question is pretty much the valid parentheses. Yeah, so I hope you enjoy. And whether or not you're a beginner or an intermediate or an expert, this video will still be very useful to you. I'm gonna go over a lot of beginner friendly basics, and so that the video would have a wider range of audience. So whether or not you're just starting LeetCode, or whether or not you have a lot of experience, this video will still be great. Okay, so the question here is asking us, giving a string that has brackets, right, and for example parentheses, right, square brackets or curly braces, right, what we need to do is we need to check whether they are valid or not. And valid means every opening bracket has a matching closing bracket, and pretty much they always close in the correct order. Okay, so think about a regular bracket. A regular bracket would always have a closing bracket right beside it, or that would be the very last bracket that was opened would be the very first bracket to be closed. Okay, so now if you were to take a look at this question, the first thing that might come to mind is, how on earth am I supposed to put this into code? And before we take a look at code, we need to think about, a step-by-step guide, right? Some sort of instructions of how we can solve the problem, right? Without thinking of any code or any methods. So when I see an opening bracket, right, any of the three, I don't know if it's valid or not, right? So what I need to do is I need to wait and see what the first closing bracket will be, okay? And also another thing to note is the order, right? Like I said earlier, the last opening bracket, right, should be the last opening bracket that I opened should be the first one that's closed, okay? So you can think about it kind of like a stack of plates in the kitchen, right? The plate at the very top, right, should be the very first plate that I take off, right? Okay, cool. So my plan that I have is, first of all, we're going to walk through the string of characters, character by character. And once we see an opener, right, we're gonna push that onto the stack, okay? And once we see a closer, right, we're gonna take a look at our stack, at the very top of our stack, and see, do they match? And if it matches, right, perfect, right? It's going to be taken off the stack, and at the end we want to make sure that there's nothing left over. Okay, so an empty stack means perfect. you know um by the end of the program, an empty stack means perfect. Yeah, it was valid parentheses. We would want that to return true, right? And if not, it would return false at every other point throughout the algorithm. Okay, and an important note to think about it as well is time and space complexity, okay? So if we're going through each string only once, that would be O of n time, right? And the stack should hold all characters at the worst case scenario. It could. So that would be O of n space, right? And that should be the best we can do here, because we do have to look through every character at least once. All right. And let's jump into the code, right? So cool. Once we take a look at the code, we see we have public boolean, so we're returning a boolean, right? So that's going to be whether true or false. And the parameter we're taking is a string called s, and that's going to have all the different parentheses. Okay, perfect. So the first thing that we want to do now is we want to make a stack, okay? And this is where we'll keep track of all our opening brackets, okay? Opening brackets that have not been matched yet. So how we make a stack would be, we start off with typing the keyword stack because we want a stack, right? And then we're going to put in the type of data that's going to go inside of a stack, okay? We're going to put in a character, right? Because remember, we want only the character inside of the string, okay? So that would be, if let's say for example it was a letter like dog, right? DOG are the 3 characters inside of the string called dog, okay? Cool. And then what we want to do next is we're just going to need to give it a name, okay? So we're going to give it the name stack, right? And once we give the name stack, we're going to say we're creating a new type of stack. And yeah, perfect. Okay, so what we're going to do next is we need to loop through each character inside of the string, okay, one at a time, okay? So how we do that in Java would be, we'll do something like for int I equals 0, and then s.length, and we're going to do I plus plus, okay? Cool. So now what we want to do is we want to take, right? We want to take the character at each position of our string, okay? So how we're going to do it is char dot char s, sorry, because s is our string or taking in, remember, s from up here, and s dot char at, okay? And what char at does is it's a built-in method that takes, right, and takes a character from a string, okay? And we're going to take it at position I. And the reason we're doing position I is because, remember, I would be the first position inside of the string. Then, because it's inside of a loop, we're going to move forward to the next position, then to the next position. And what we want to do is we are going to place these inside of a data type of a character called C, okay? Perfect. So pretty much what we're doing is we're telling, hey, string, right, dot char at, give me the position of the string at position, let's say 4, and it's going to give us, for example, in this case here, 1 2 3 4, right? So once the loop reaches the 4th position, right, it's going to give us this, okay? Perfect. So now what we want to do is, if we see an opening bracket, we don't know its match yet, so we're just going to save it later by pushing it onto our stack, okay? And this is going to be done inside of our loop, okay? So if, right, if C is equals to our bracket here, what we're going to do is, what we're going to do is we are going to do stack dot push, right? And we're just going to push C, okay? So what we also want to do as well is we don't want to cover just this type of parentheses only. We also want to cover all the other types of opening brackets as well. So how we do that in Java is we have this special key here called OR, okay? So we do just like that. So it would mean if C is equal to just this type of opening bracket, or if C is equal to this type of opening bracket, or if C is equal to the square type of opening bracket, okay? That's when we put this onto our stack, okay? So far the code is very, very, very easy. There's nothing very complicated going on right now, okay? So cool. So now what we want to do is we want to see if the closing bracket, right? We're going to do now, we're going to do, if it's a closing bracket, right, we check, okay, is the stack empty, okay? So how this works, right, in theory would be, how a if statement works is if, right, it's an opening bracket. So if it's not an opening bracket, what would it be? It would be an else, right? So what goes on inside of our else statements, right? So what we want to have is here is, before I try and match it, let me check, okay? is my stack empty, right? And if it is empty, that means I have a closer with no opener, okay? We have a closer with no opener, right? And that is automatically wrong. So we can end the algorithm right there, right? So let's put that into code. So if, right, our stack dot is empty, right? Return true, return false. Okay. So what we're doing here is we see, for example, let's say we had, I don't know, S is equal to something like this, right? We see that we have a closing bracket, but the stack is empty. There is nothing to match with, so we return false, okay? And in case you're a beginner, I'm going to run through that one more time. So let's say S is a closing bracket. So S is going to check, okay, is it any of these? No, it's not. So we move to our else. And our else checks, is the stack empty? And it'll be, yes, it is empty. So it's going to do this, return false. And return false ends our program, okay? So we're just covering that case over there because we have a bunch of different type of test cases that work through. So now this is where the really cool part of the program happens, right? Okay, so if the stack isn't empty, right, what do we do? What we want to do is you want to grab what's at the very top of the stack, okay? So that's the most recent opening bracket, right? Now we just check, does this match the closer I'm looking at? So the opening bracket at the very top of the stack, right, needs to match wherever C is in the algorithm, right? So the first closer that we see, okay? So what we want to do is we want to take whatever is at the top of the stack, and how we're going to do that in code is we'll do something called stack.pop, right? So what stack.pop does, whatever's at the top of the algorithm, it takes it out, right? And where we want to put it is, we're just going to put it inside of car top, okay? Perfect. And once we have that there, right, for let's say in the instance that they were matching, the algorithm will continue, and then what it's going to do at the end is it's just going to return stack dot is empty, okay? Or return stack is empty, and that would be the case, right? But what we need to do, right, is we need to check that if the stack isn't empty, we grab the top, and we need to check for all the possible fail-safes, okay? So how we're going to do this is we're going to say, okay, if, right, if C is equal to our closer, right, and top, because remember, top is whatever it is, if top, right, is not equal to our opener, right? Where's our opener? Perfect. Now we can to our opener. What we want to do is we want to actually return false, okay? We want to return false. And then we're just going to do this we're going to do the exact same thing for our other two types of parentheses, okay? So if C is equal to our curly bracket and top is not equal to its alternative, what we want to do is we want to return false, okay? And then we're just going to do the same thing for this one over here with the square brackets. Okay, perfect. So just in plain English, I see a opening bracket. Okay, perfect, right? So that's where we are in our algorithm. We are seeing an opening bracket. So was the very last item from the top of the stack its matching opener? And if it's anything else but that, you return false, and it's the end of the algorithm. Okay, and we do the same for the curly brackets, and we do the same for the square brackets. Okay, because if it isn't, then it's invalid, right? And we don't need to continue the algorithm any further. Perfect. And then what we do next is, right, perfect, now we take a look at our return stack dot is empty. So now that I've looked at every character and we've seen, okay, let's say for example, right, we had tree, let's say for example, we had, our question actually had our S was equal to 3 openers in a row, right? And let's say we pushed these 3 openers, but we never found closers for them, right? So what that would mean is, that would mean our stack has 3 open brackets inside of them. And so we would check, right? Is the stack empty? And if it's empty, everything worked and it's perfect. But if it's not empty, there's leftover openers, okay? And that's why we're returning stack.isEmpty. Okay. All right. So yeah, that's pretty much our question sorted, and I'm just gonna run it now just to show you that it works. Oops, it looks like we're missing something here. Missing a return. Sorry, we might have a return inside of our loop. Yes, we do. Yes, we do. Perfect. Okay. Perfect. And we've passed all the test cases. So just to summarize, we use the stack because the brackets follow a pattern, right? So the last open bracket, needs to be the first closed pattern, right? And remember, there's 3 ways it can fail. So it can fail if, there's a closer that doesn't have an opener, right? So I mean, the stack is empty. And then the closer, if the closer doesn't match, it's the wrong bracket type. And if there's openers left over, the stack was not empty at the end. Just to reiterate again, our time and space complexity are both O of n. Time is O of n because we only pass through the string once, right? We only need to pass through the string once, and space because worst case scenario, all openers on the stack. And that's pretty much it. Please leave a comment below. Let me know if you would prefer a more faster type of video, because I did take a little bit long to explain certain parts and go into a little bit more depth. Please leave a like on the video. It's very encouraging. And yeah, let me know what you'd like to see next.